go. All right. Well, it's a pleasure to meet you folks. Let me just get this toggled to presentation view. There we go. So my name is Scott Unger. I'm the channel account manager for InfoBlox based in Austin, Texas. I've been with the company for 10 years, actually, quite a long time. And with me in the presentation, we have Mike McIver, who's the systems engineer that I'm coupled with. He's going to be running the demos today. And then we have Jimmy Campisi, who's actually a security product specialist with us, is also going to be adding color commentary and talking about DNS security when we get into that section. So that being said, we'll jump into this here. We actually added some specific content around service providers. I did a bunch of research on this before we started. So this is not just a generic InfoBlox presentation. I'm going to talk a lot about how we apply to your market space. So just a little background on InfoBlox on the front end. Company's been in business for 20 years. We're actually closing in on over 9,000 customers, contrary to this slide. Always have done very well with the larger customers. You think the tier 1 service providers, the largest federal customers, 95% of the Fortune 100s. What we're seeing is actually a very, very strong movement downstream into the marketplace. InfoBlox, the last 2 years, has had more growth in the last 2 years, even in the COVID economy, than it has in its company history. And a lot of the reason for that is that what's happening in the technology sector and the way that people do networking is pushing people to need commercial grade DNS, DHCP, and IPAM. So think about IoT as an example, right? Your customer networks that you're providing services to are bigger. They have more devices on it. Therefore, you're getting more DNS traffic. A case in point example of this, we had a corporate account, which was an oil and gas company in Texas. Last quarter closed a big deal for security with us. They told us they had 1 billion DNS queries going on a day in their environment. That's 1 billion, right? So I was used to hearing, oh, we got 20 million, we got 50 million. Well, 1 billion DNS queries going on a day. How do you know if that traffic is secure? How do you know that it's even legitimate traffic, right? That you're not even DDoSing other customers as a corporate account? How do you know that infected endpoints are talking to command and control servers? Or even worse, infected endpoints are exfiltrating data over DNS. You look what's happening with multi-cloud environments. I don't know how applicable this is, but you know, all those different cloud environments have their own DNS architecture. Amazon, Azure, Google, right? You could be supporting Linux bind internally. You could be supporting Microsoft internally for DNS, right? All of a sudden, I'm supporting 5 different flavors of DNS, and there's no centralized management. There's no centralized configuration. There's no visibility. There's no reporting. So the cloud piece is driving it to us. And I would say automation is another big, huge piece of people coming to our marketplace. People don't want to open up help desk tickets and manually administrate DNS anymore. They want that to be an automated feature. And that certainly applies to your marketplace as well. Whoops, did I grab the wrong slide? I did. Let me go to the right slide. Hold on. I knew that didn't look right. So just regarding the service provider marketplace, understand, let me fix this. Sorry about that. I grabbed the wrong presentation. Hide. Whoop, nope. 1 second here. As soon as I'm on track, we won't have to do this again. Hide presentation view. We have a massive presence in the service provider marketplace. In fact, we have our own team of service provider salespeople that work with the tier 1 operators. So you can see some of the names that are in there. They are our largest customers, I would say. And what we're seeing out of these large service providers, and certainly it applies to everybody that's on this call, is they're looking to unlock revenue generating opportunities with InfoBlox, specifically around security, right? And how they're monetizing it is safe internet, parental controls, IoT security via DNS, and ad blocking. You could almost think of all of your customers and all their devices on their network as being IoT devices at the end of the day. You don't need to necessarily dictate or manage them, but you want to make sure that they have a safe experience and that they have a good experience. Here is an earful of a slide, and I'm going to talk at length about this. I put all this up there so you can read this while I'm talking about it. From a DNS security perspective, there's 2 main things that we do. Volumetric attacks, we developed the advanced DNS protection platform for the service provider marketplace. I remember when we launched it, and the issue was people get multi-gigabit DDoS attacks over DNS. How do I do 1 million DNS queries per second, maintain line rate performance under that kind of an attack load? ADP was designed to do that, to look at what's good traffic versus bad traffic. Security signatures were actually developed as an afterthought because we launched that product, I'd say about 8 years ago. We actually do our signature-based technology on the ADP platform. But you don't, end up in the Wall Street Journal or have a compliance violation because of DDoS. That can, be revenue impactive. The real problem that we're seeing right now, and this is what the clients are experiencing, is around what's going on under the covers. What is that infected device doing over DNS, such as talking to a command and control server, such as exfiltrating data, right? Are the bad guys actually using malware and using DNS, which is a bidirectional network communication protocol, to do exploits? I want to tell you a story here. There was a gentleman I was trying to get on the call, but he had a conflict. His name's Paul Flores. You have a 50-50 chance if you're based in Texas that he's your SE. He's the Southern SE for us. We were talking to a Louisiana-based service provider, and they said, hey, I think we're having problems, and they opened up a help desk ticket with their InfoBlox platform. They were using us for DNS, right? They wanted a high-performance platform. They really weren't using any of the security features or some of the other things that we're going to talk about. Paul goes into the box, he looks at it, he goes, I don't think there's anything wrong with the box. I think you're getting DDoSed. So what they did is they turned on just the security heuristics and machine learning portion. They didn't turn on reputation. They didn't turn on whitelist, blacklist. All it was is, let's do some machine learning on this traffic and see what's going on. Lo and behold, their customers were sending so much bad DNS traffic to that box, it DDoSed it and was knocking it over because they didn't have an ADP platform. If it was an ADP, it could have handled it. It was just a standard InfoBlox DNS appliance. So what does that tell you about your customers and how you think about DNS in that perspective? Does it make sense to look at the reputation, behavior, and signature of what's going on? Now, this customer, the way they handled it is they actually said, you're violating your service level agreements, and they turned them off. That's what Paul told me. But that's an opportunity to monetize this. And that is what is happening with the tier ones. When I talk to our service provider team, I'm actually working a fairly big project with one of my partners because I'm a channel person. I'm not a direct sales guy. EdgeTeam is my customer. And we're seeing people monetize this because we are able to clean that traffic in the cloud. In other words, and you'll see this as we go through the security presentation. If that infected device can't talk to the command and control server, it doesn't get an instruction set. If it can't talk to the ad server, it's not getting advertising information, right? And on and on and on. And the awesome thing about this, and this is another thing that service providers want, is they don't want to install anything on the endpoint. With DNS security, you're cleaning it from a DNS perspective without having to actually go in and touch the endpoints and install software on them. I'm going to pause. Are there any questions from the people on the line? This is quite a bit I've covered here so far.
Have any questions?
Okay, no questions at this point. Okay. So that being said, that's just a little bit of the specifics on service provider. I actually have backup slides that you're going to have access to that go into details at the end of this presentation, talking about each of those categories. What are we doing for safe browsing? Because actually we can do that as well. Parental content filters, ad blocking, right? And then the DNS security piece is stopping command and control and exfiltration and all the really nasty things that we can do for the clients. There's extra slides you can review on that. So let's just talk a little bit about DDI. DDI stands for DNS, DHCP, and IPAM. And that is the core services that we run on our platform. So this is what your environment would look like if you're not using us today. You would be using essentially freeware to do a lot of these services. You'd be running your, more than likely, you'd be using a spreadsheet to manage your IP addresses. You would have something like a Microsoft or a Linux server to do DNS. You might have a router doing DHCP, right? And none of this is centrally managed, right? There's no reporting services around it. There's no specific security services built around it. It could be susceptible to DDoS attacks, as we've seen quite heavily in the marketplace, even as recently as last month with that customer we talked about in Louisiana. It's a manual process for everything. And this is a huge point to make, is that if you look at us and you say, hey, I want InfoBlox just to be a high performance DNS server, but I'm not going to look at IPAM as an example, which is IP address management, you're missing out on an opportunity to automate. The more of these services you bring together, as you'll see on this next slide, the more value we're going to have. So what kind of automation would you do around IP address management? Well, instead of having a network person or a Linux person administrate IP addresses and administrate DNS records, that becomes automated. Because what we do with IPAM is we actually put a discovery service in it as well. And we're actually able to go out and we're able to see all the layer 2 and 3 devices. So we call this authoritative IPAM, right? I know that it's Bo, and he's got this IP address. He's connected to this Wi-Fi access point. Here's how he's connected all through the backbone of the network. Here's his Active Directory information. Think about how valuable that metadata becomes from a data center and a security standpoint. And that's where we roll into this type of environment. And we'll talk about the onion here. You know, all these services are interconnected. And you know, when I listen to our engineers talk about this, what they talk about mostly is you need to change the way you're doing your operations, right? If you just look at it as the same old, and you don't change your processes associated with it, you're not necessarily going to get the return of investment. An example of this, we had a utility company that presented to us that had 6 people administrating a Microsoft freeware spreadsheet type environment. Post InfoBlox, and they want, you know, with the whole solution, it was halftime of 1 person managing all that. Why? They automated everything because they were using authoritative IPAM, right? And we have APIs and add-ons that work with all the private cloud hypervisors that'll get you to there. The big piece of the IPAM is the security piece, and it's that context. And we're going to get into that very heavily as we go into the next section. So DHCP, that's where we get fingerprinting. That's where we get information about the device type, information about the lease. And you can see the more of this that we do, the more pervasive the install is, the more we're able to get to that outer layer of automation, true security, reporting, provisioning, right? When we do all these services combined and we have an end-to-end type environment. Pausing. Any questions? Comments or color? Mike, do you want to put any color on this? I'm going to ask you to, if you want to put any color on it. You're muted if you're talking.
No, I was double muted. That's how quiet I wanted to be.
There you go.
No, I was going to say the big thing for the service provider market, you know, that I think is key is the automation and the power we give you with APIs, right? So, you know, when we start talking about these product families and what we can do, and you'll see some demos later, you know, the bigger one is even to our administrative interfaces, we have APIs. So I've seen different companies starting to write their own portals for customers so that they can self-serve a lot of this stuff. And it really is modeled after the service provider, you know, mantra of, you know, one-to-many management model, where I can sit at one console and manage a whole bunch of things. And so we've really built a lot of industry standard hooks through RESTful APIs and things like that, many more, but that's one of the top ones, to allow you to kind of customize what you want to offer the customer and actually let them do some self-service on things you want to allow them to do. And it ties into all of this stuff here.
All right, perfect. Okay, let's jump into DNS security. So I'm going to go through a little bit of the life cycle of what malware does with an infection. So let's play this out. I'll use Juan. It looks like he's with Valley Telephone. So let's say Juan has an infection on a device and he goes into the network and he plugs into the network and there's advanced persistent threat malware running on Juan's device. What's the first thing that infected device is going to try to do? It's going to try to talk to a command and control server to get an instruction set. And it's done typically via DNS query. So that device will go to badguy.com, thief.com, newbaddnsserver.com, whatever it is, and say, hey, what am I supposed to do? And DNS is a bidirectional network communication protocol, and it'll come back and it'll say, go east-west in the network and steal credit card information, as an example. So maybe that's what it tries to do. So here's the dumb question. Was DNS used in this example? Yes, of course DNS was used in this example, right? You're commuting out onto the internet to a server. You're going to use DNS. East-west, he goes and talks to the accounting server and starts trying to fish and find you know, credit card information or financial information. And it's not him doing it, it's the malware running in the background that does it. Is DNS used in east-west communications? Absolutely, DNS is used in east-west communications. Now that he has something on his device, or the malware does in this case, Juan doesn't know it because that malware is ticking quietly in the background, and wants to exfiltrate that data out of the environment. So here's how DNS exfiltration works, and you're going to see demos on this, is the bad guys will stand DNS servers in the wild that have query logging turned on. So they're really not even DNS servers. Yes, they may respond with an IP address. They may just give you an NX domain, no IP address found. But the point is they're collecting every DNS query, every text record that goes to it, and then they're going to build that information up and dehexify it and turn it into data on the other side. So when data exfiltration over DNS is DNS used, absolutely. It's a little facetious and it's a little redundant, but I'm making a point. Here's the point of this, is that in the cycle of malware, DNS is going to be used all the time. It's guaranteed. At some point, DNS is going to be triggered. What if you had all this phenomenal information in your IPAM tool because you're using us for DDI? What if I knew the username, the device type, right? The IP address, the MAC address, even the virtualized information, because we have plugins to all the virtual hypervisors, all the way up to the router and switch information. And I could say, okay, at 11 o'clock in the morning, it looks like Juan did an indicator of compromise. He was communicating to a Russian botnet server trying to get command and control information. We can take that information and send it via an API call to 80 different security vendors right now. We can send it to your firewall to take an action. We can send it to your network emission control system to take an action, right? We can even package it up into a ticket into your ServiceNow ticketing system or Splunk. And all of that's done automated without any human intervention. And that is freaking awesome if you think about it. And that's the difference between using a network-centric company, because we're the network backplane. We're involved in every one of these IP and DNS communications, and then leveraging that into API calls. All right. So here's some of the ecosystem integrations that we have. Understand that we are completely unique in the marketplace doing this piece. There is nobody that's doing this. There are definitely DNS security competitors that are cloud-based. Cisco OpenDNS is a good example of that. There's several providers. When you go premise-based inside the network with all this actionable intelligence about the users, we're really the only game in town right now that has that hybrid model. And yes, of course, we have a cloud-based system as well. That's our Blox One DDI system. Mike is going to do a demo that shows you exactly how this works at the end of this presentation when I turn it over to him. Any questions from the group on what I just covered? It's a lot. It's an important concept with InfoBlox. DNS is the #1 attack vector. There are so many examples of, Chipotle's hack was DNS exfiltration. The latest SolarWinds attack was preventable in our customers that were doing, cutting off communications to that command and control server. That's the thing that needs to be cut off. Here's the question for you guys philosophically. Does it make sense to have a dedicated DNS security system above and beyond your firewall at this point? For the service providers, there's a double benefit in the sense that you can prevent all that nasty client-based DDoS stuff coming to you guys. But does it make sense to clean it in the cloud for them? Here's what we're seeing is that reputation filters alone are no longer sufficient. So if you go back, say, 5 years, just doing a reputation white and blacklist, something we'll call RPZ if you use Linux bind, thief.com is bad, but brand new DNS server, it's not going to be covered by your reputation list. And what's worse is we're seeing things like fast flux and domain generated algorithms where you can change the nature of the IP, you can change the nature of the .com of the target server that people are trying to exfiltrate to or talk to get command and control traffic. And what we're seeing is it takes a long time for people to catch that there's DNS issues going on in there. You look at what the SANS Institute is saying, you look at what Forrester's saying and others. SANS quote, the inclusion of DDI data should be a security requirement. We need the user and device context for incident response. In this situation here, if we package all this up the way Mike is going to show you, think about how that impacts your security operation, how quickly you can find and locate those devices that are having problems and remediate them, right? So philosophically, we're going to the customers and by the way, the market has spoken on this. I mentioned that InfoBlox is having its biggest years ever in the past 2 years. If you look at the anatomy of any of our larger six-figure, multi-six-figure, seven-figure deals, DNS is a huge piece of the equation for them because they want to have this context about the users. They want to be able to take advantage of the ecosystem. This resonates very well with chief information security officers as an example. So the other point of this is that, and this is the point too, blocking malware early in the life cycle, it never becomes port 80 traffic. It never hits the firewall. It never hits the web proxy server, right? You know, think about how DNS works. Okay, I need to know the IP address for thief.com. Sorry, you're done. You're talking to somebody you shouldn't be talking to. It doesn't then become port 80 traffic and try to communicate to thief.com, right? And that can take a big load off of your firewalls. We are the DNS server. Taking something like a next-gen firewall and trying to do DNS inspection on there is the wrong place to do it, especially when we're hearing customers telling us that they got a billion DNS queries going on a day. And I know you guys as regional service providers have big numbers of DNS queries. Pausing, any questions? Any questions, any comments? Getting towards
I'd like to add one, Scott, and that is,
sure.
You know, I think there's huge market opportunity here because, you know, we're seeing tremendous growth. We're going down market. We're getting to more customers. With COVID particularly, right, there's a lot of work at home customers. And at the first phases of COVID, you know, people were going out to look at the coverage maps of where it was. And a lot of those were hacker sites, right, that was putting these malware and ransomware droppers out on company computers. And it wasn't being seen and it wasn't being handled, which is why we're seeing droves in the states at least come to us for a solution to fix this. And where there's that kind of market growth and interest, there's huge opportunity for revenue generating opportunities, especially for service providers.
Absolutely. Last point, because this is going longer than our normal sections, and I want you guys to see Mike's overviews, is that, you know, everybody has some measure of DNS protection from their firewall. We know that. You're going to know about reputationally bad sites that you shouldn't go to. You're probably going to have some signatures as well. What's missing is the machine learning piece, universally across the board. We don't see that in any of our competitors right now. And I could tell story after story of us going out and doing a data exfiltration demo for a customer, which Mike's going to show you. There's actually a 10-minute process you can do to check your environment to see if your DNS would block a day zero vulnerability. And Mike's going to show you how to do it because I want to get to him quick. Those aren't caught by signatures and reputation. The only way you're going to catch the day zero vulnerabilities, meaning it's a unique DNS server out there. It was stood up for a specific customer. It's got a unique IP. It's got a unique .com, is to do it via machine learning. And we see this time and time again where we go into a POC with the customer. They go, well, we think we're okay. And then they run our technology and they find active tunnels running and exfiltration happening. Take that service provider in Louisiana. Paul Flores, if you're south, if you're Austin, San Antonio, Houston, ask him about that. It was eye-opening for this customer that they had something like 8 customers sending gigabits of bad DNS traffic at them. Cut them off, right? Or help them. That's the right answer is monetize and help it. Okay, I am done. Mike, could you kick into the ecosystem demo, please? Because I just want to keep this on time.
Certainly, the ecosystem demo is fixed length, but the other one I can kind of speed up, and I'll go ahead and put myself here on camera so that you can see me while I'm talking. And we will share this one. And so we're going to walk through a little scenario here, just showing some of the ecosystem. And this is just a sampling because obviously we've got 80 plus different third parties in the market that we assist in becoming the early warning kind of device for what they do. But I'm just going to walk through a standard day in the life of a couple people and then show you what's going on in the back end. And this is available to you if you guys would like to, you know, take a look at it. It's easy to do. But we're going to start with Bob here, who's running in an unprotected environment. And he's sitting at home working during COVID, and he's dreaming about going to Hawaii on a vacation when the travel restrictions are eased up enough that he's comfortable with it. And so on a break, he goes out here to this Fly Easy site, and oh, look at here, offer you can't resist. Who's not going to click on that, right? And he goes down here and it says that there's some little thing that needs to be installed. He goes, well, it's, you know, a site I'm going to. He clicks on it and he gets this. And when he starts looking at his data files, he finds that they've been encrypted. And Bob has just been hit by a ransomware attack. And I don't know if you saw, but over the last week, there's been an influx of ransomwares going on through different ways to get into the network, even through things like NAS for homes and things like that, where they're launching their denial server, the ransomware attacks. Alice is going to do the same thing, but in her case, she comes right to the splash screen that says she was either explicitly blocked by corporate security or it was identified as malicious, and she was protected. And if we look at what happened with Alice's case, there's a lot going on in the background that ties into automation. So first thing is, she went out to the DNS server and wanted to go to this site, and we either knew through one of our three methods that it was a bad site, and we sent her the splash screen and said, no, you can't go there, right? So we denied her giving her the IP address so that that bad software could talk to the command and control server. But in the background, we've also sent out information to Splunk, ServiceNow, endpoint security systems, firewalls, the whole bit. So if we start looking at ServiceNow, when this incident happened, a ticket got automatically generated, and there is a ton of information in here. So we can see who the client was, who they were going to. It was blocked by InfoBlox. Fortinet put in a block rule for that bad site to protect the rest of the clients. Tenable scanning the endpoint, Rapid7 is, and we sent some stuff over to Splunk for our audit trail later. When we look at the firewall, automatically, again, no human being has touched this. Down on the bottom line there, we see an InfoBlox RPZ for the IP address for that bad site. So now anything trying to go from our network out to that site is going to be blocked at the firewall, which it does very, very well. If we go look at Tenable here and click into its user interface, we can see that there's a scan running on that machine. And by the way, when that scan's done, it'll obviously report back to ServiceNow and Splunk that it completed successfully or not, which allows a security team to very quickly go see what has happened and whether they need to do any more work on it. Same with Rapid7. If we drill into Alice's computer here and look, we'll go down and see that, in fact, a scan is in progress. So again, this is all going on automatically. So we're really enabling all of these other tools to work very much better. Our particular IP address management database uses Splunk as just a reporting engine. And we can go in here and we can click and we can start looking at points in the network and things that are going on and hop around. But instead of doing this, where we get a lot of benefit is all the stuff's already in the ServiceNow ticket. Everything's already in the Splunk listing. So, and they're hot linkable. So right from there, we can just click on it and go look at the different administrative tools to see what's going on. If we go out here and look at our advanced reporting and see what's going on, and we scroll down here, we can see that I tried to access FlyEasy. I ended up being redirected to a site called Copalter. If I look below, look at this information. There's the host IP, the source UDP port, what kind of traffic it was, client IP, device type, device name. Right, so all this information is actually being pulled out of the IP address management database and used to help populate the security tools, so we now know exactly what endpoint, not just from an IP address where I have to go scan to figure out where it is, but more information. It's a Windows box. It belongs to, Sam, or Alice. And the information is all right there, easy to get to. And in fact, we are hearing from our customers that it gives them about a 60% decrease in time needed by a person to go look at some of these indicators of compromise. Now, if we go out here and do some pivots, right, we see the FlyEasy there, we see Copalter, and we want to know maybe who else is going to Copalter within our network to make sure that we've got everything cleaned up. And again, this kind of information could be monetized. And so we're going to do that using data pivots out here. And if we look at all devices with Copalter in the domain name and click on this, we can now scroll down here and look and see who else is infected in the network. And we're seeing that there was 4,200 hits on Copalter. And if we look here, we can see a couple that have had a few DNS queries go out, but one that has been blasting DNS queries out. And while I'm no mathematician, if you're to take 4,200 DNS queries by, let's say, 23 bytes per query, you can calculate how much data has gone out in a potential data exfiltration from that one PC out there. And we could drill into that and go remedy that very, very quickly. So this is just a quick sampling of how we're using automation with other security tools in the stack to first of all, find this very quickly, and then let the other tools do what they do well, and then give the security team what they need to very quickly go see, is this anywhere in the network, and mitigate the problem very quickly, very easily, in a very clean method. So with that, I'm going to switch shares here for a minute, because I'm going to share my desktop and show you one more demo. And this one I can go a little quicker on. I'm just going to share my desktop with you. And what I'm going to do is I'm going to go out here to a web page, and we have this tool called DEX, which stands for Data Exfiltration. And I'm just going to go out here and log in. By the way, I can work with EdgeTeam if you guys want to try this. Any of you, we can actually get you a 2-week limited access to this tool so that you can try it yourself. And, you know, we start out here by kind of explaining how this works in a very simple way. I have an infected host here. He can't get directly to the internet because I've got good got good security in the corporate network. So I send out a DNS query. The corporate DNS server doesn't know where to send it. So how DNS works is it forwards this on up a hierarchy of servers until it finds somebody that knows who that server is. And once they do, it hands it back to the corporate DNS server that hands it to the client. And now I can start sending those DNS queries out. In this case, it's to thief.com. Okay. Now, the bad guys have just in Azure or AWS or wherever set up a target DNS server, and all this guy has on it is query logging, which means every DNS query that comes in, it's going to record. That's all it does. And it's going to send back a message saying, I don't know where this DNS site is that you're asking for. And this is all 100% completely legal DNS traffic. Now, if we look at what's in front of the thief.com, that's the actual data. So I've taken a file, I've run it through an operating system tool that converts it to hexadecimal. I've chunked it up into appropriate length bytes of data. I've appended the thief.com to it, and I send that out as my DNS query. When the target server sees it, it knows that this is junk. Well, it's not junk, it's actually data. So it just stores it using query logging. And once I have all of the packets or the DNS queries together, I can take and put them back together, unhexify them, and now I have the data file. So that's how this works. Let me show it to you. In this particular tool, we've got 3 different ways to do this. We've got a text decoder, a script decoder, and hexify, and then we show transferred files out here. And let me clean these out so you see everything new coming in. And we're going to start right here. And I can very easily type in a sentence. Let's just say service providers are the backbone of the internet. Okay. When you watch me type this sentence up here, if I go down to the first gray box here, we'll see that I've created DNS lookups, right? So I'm doing an NS lookup. It says type A. I can change it to any type record in the DNS legal hierarchy of names. This is important because some of our competitors only do like the top 3. And so if I'm a hacker, I'm going to try all of these until I find something that works, right? So you kind of have to put on a hacker mindset. But what I did was I took and I converted this to hex. I split it into the appropriate length to be a DNS query, and then I appended some information to it. And I'm going to send it to this very innocuous looking JS barbecue supply company, which is actually a bad server that we have running out in AWS. And you'll notice that even though this is a very short lineup here, it took 2 DNS queries. And if I come up here and I just grab the first one and I copy it and I go out here to a command line, let me make this window just a tad bigger, and I paste this guy in and I hit enter, it's going to say server can't find this. I get an NX domain, and that's the remote server, the bad server telling me I don't know what to do with this. And that's normal DNS activity. But if I go back here to my page and I look at step 4 down here, look at here, I've got service providers are the back. Well, if I want to complete that, I can just go down here and copy the second query and put it out in my command line here and send it and do the same thing. And again, I get my NX domain, which is perfectly legal, but now I'm looking at the end DNS server out in the cloud, and look what I got. I got all of the data that I put in here down at the remote DNS server, simply using DNS queries. So that's the simplest way to do DNS exfiltration. Now, to just show you a quick way, and there's multiple ways to do this, but thinking about a hacker, I'm not going to do this command line. I'm going to write a script. So I could do something as simple as go out here to my desktop, find a little file just for time's sake, this PDF on writing SMART goals. And I'm going to say, let's do MX records this time because why not? And I'm going to hit generate. And this little application writes two different scripts, either a Unix shell script or a Windows PowerShell. So if you want to try this and you're more familiar with one than the other, you've got your choice. And again, I can go copy this. And I can go out here, and I have to be in the right directory. So let me go to my desktop, and I paste this in, and I hit enter. And what we'll see is I'm sending all these DNS queries out, and I'm getting these NX domains, okay? Now, if I go back to the tool and I look at the filed transferred messages, I can see here that the DNS script decoder worked, or the text decoder worked, and here's what it sent out. And now I can see that I'm getting this file called SMART goals, and I've got 94 of the 510 DNS chunks it's going to take to get the entire file out. And if I refresh, we'll see that it's updating. And it only takes about a minute to get this 14K file out. Now, when I'm all done with this, I can actually just click on this and bring up this PDF right in my web browser here to show you. While that's going on, though, I want to show you one other thing. And that is, if in the script decoder here, I want to be even more hacker-like and not just blast these DNS queries out one after another, I can choose this new. So keep in mind, people are constantly looking at bad servers or bad types of traffic. And if I'm blasting out DNS packets to the same DNS server just repetitively like I'm doing, that'll flag a lot of people saying, wait a minute, this is kind of abnormal behavior, right? It's a little more difficult in that even though I'm blasting out these DNS entries one right after another, it's interspersed with all the other DNS traffic on the network, which makes it a little more challenging. But when I go to this script, the new script, and I hit generate, I'm going to go from 4 lines of code here. Watch this. When I click generate, I now have 8 lines of code. So now I'm like a hacker adding more things in here to obfuscate the code. So if I go in here and I grab this one, and we're not going to complete this one, but if I go out here and look, and I paste it in here and I hit enter, first thing we're going to notice is I've only seen, oh, there went a couple more. So I put a random time delay in how often the DNS packets go out, which further obfuscates it. And then if I look here, I'm just going to JS Barbecue Catering. I'm going to Double Barbecue. As we look down here, it's from Pandemic. And so I'm sending it at random times. I'm sending it to different looking DNS servers. I'm sending out different record types. There's a text, there's an A, there's an MX, there's an SRV. So I've entered in all of these different things to make these packets look different to somebody looking for a pattern, right? And that's called things like domain-generated algorithms and fast flux. And that's where our heuristics and machine learning come in, because we're looking at this from a cloud level saying, I've seen this stuff elsewhere. I'm seeing it here. This is not adding up into our patented algorithms. This is a bad site, so I'm going to go ahead and block it. Now, if we go back here, just to finish this up to transferred files, we'll refresh and click on SMART goals here. Oh, must have ran into the fact that I'm actually running. If we look right here on the top side of my screen here, I've got this little green cloud. That is InfoBlox's threat defense security running. So 307 DNS queries came out. It recognized it and it went, I'm not letting you go anymore. So we actually blocked it, and because we started seeing bad behavior, I actually caught the more complex one in 33 packets, or DNS queries. Now, the reason I want to point this out to you is if I had caught this on the first packet or the first DNS query, that means I had a signature looking for the barbecue domain name that I'm sending things out on. But because this particular one was using all those different record types and all the different, you know what? I'm overstepping. It will stop this one, but it's just going out slower. Because this one has so much more in it, I'm still going to find it and stop it out here. And with that, Scott, I'm going to hand it over to you to see if there's any questions.
Yeah, so any questions you guys might have on DDI, service provider marketplace for DDI, or security, Jimmy's on the line. He's our security specialist for the region. He's got a lot of insight into what we're doing at other customers, for example. Just open questions and answers at this point, folks. And we have some customers on the line. If you guys wouldn't mind, if somebody that's actually, I definitely know there's some people that are using us. Any sort of use case or best practices. We don't have too many people here. Let's have a talk.
Hey, Scott, I got a question. This is Corey. My question is, if in the demo that the first video that Mike was doing, you guys were utilizing a lot of different security tools from the automation standpoint. So in an environment that may only have a handful of those tools, it's not a requirement to go out and get all those tools to make it effective. So how does it, in that mixed environment that may not have all the tools that you guys are showing in the video, how are you able to utilize the information that you got to also see and act upon the bad actors that you're seeing?
That's perfect. Let's have Jimmy answer that, please.
Yeah. Thanks, Corey. That's a great question. And so, so the way we forward the information first is open APIs. So we really can work with anyone. So we learn what our customer's environment is. We have 80 plus supported partners. All that means is they can get InfoBlox support if they're formally supported. But even if they're not on that list, any vendor that will accept an incoming API or REST API, we can work with. The data that we forward, and I think it's more specific to your question, is really twofold. Number one, it's the user and device information that we get from DDI. So let's say we have a DDI customer. We can get things like DHCP fingerprinting and IPAM metadata because we know the MAC address, the IP address, the device type, et cetera. So that's the first valuable goldmine set of data that we can pass on that API. The second piece is the threat information. So let's say somebody clicks on something that they shouldn't click on. They're going to go and get blocked by our product, Blocks One Threat Defense, and that's going to send them to a block page, and that's going to automatically trigger the ecosystem. So any of those open APIs that our customers set up, because they're one of our supported relationships, or maybe just somebody that they wanted to set up an open API with, we're going to forward that information over to them so that they can apply their own security policy. So for example, if we know that there's an infected endpoint and maybe that endpoint needs to be scanned by Tenable or Rapid7 or somebody, then we're going to send that data over and make sure that that scan happens. And then that we can also communicate to the network admission control vendors so that they can quarantine that infected endpoint and make sure that scan happens and not allow them on the network until that scan. So there's DDI context that's valuable goldmine of information, and then there's threat data via the incident of compromises, and we can customize that data to make it most effective based on which vendors the customer uses and which open APIs they wanted to set up. Did that answer the question, Corey?
Yeah, I believe so.
Yeah, that was good. Thank you, Jimmy.
Well, and I think to the point too, let's say they just have a firewall and InfoBlox, right? InfoBlox can block them going to that DNS site, but it can also go out to the firewall, regardless of who it is, and say, put in an access control list saying, don't let anybody on the network go to that IP address, right? It can be that simple.
Yep.
If they have endpoint scanning, we can fire that off. If they've got access control, we can add that in. So it just depends on what the customer has and wants to connect into the overall early warning system that DNS gives them.
Then I want to make this point as well, and I think you could infer it but I just want to make sure it's spelled out very clearly. Let's say you had just an InfoBlox DNS security box in the militarized zone next to your firewall, and that's all you had, and you weren't using IPAM. We wouldn't be able to do all this stuff that we're talking about. We need the IPAM data. You need to be using IPAM, and we also need to be deployed pervasively as well, right? The more pervasively we're deployed in the environment, the more metadata we have that we can take advantage of. Does that make sense?
Yes.
And one more comment, this is Jimmy. It really, what this ends up resulting for our customers is an ROI. So I was at Cisco in security and cybersecurity for 17 years before I came over here. And it's very difficult to find an ROI when you're purchasing security products. You're typically just trying to reduce risk. But with our product, because we tie into the rest of the security architecture, we make it all smarter and more efficient. And we can bring our customers an ROI by working with those other partners and by blocking it before it gets to the firewall, before it gets to the web proxy, we can free up those valuable resources. So we have an ROI that can help our customers get this product funded, et cetera, in a way that other security technologies typically don't have.
Yeah, absolutely. Good. Any other questions? I do have a bunch of additional content on the slides that I didn't cover. There's a lot of back-end information where you can go deeper, and we'll share the video back to EdgeTeam, and then we'll include the full deck that has the backup slides that I think you can go a little deeper on. Anybody here, we have account teams. So actually you wouldn't be speaking to us again. You'd be speaking to our account teams plus Jimmy, our sales reps plus Jimmy, if you have more interest in security along with EdgeTeam. We appreciate you guys taking some time, and we'd love to. I mean, obviously DDI is important to service providers. It could be a DDI only conversation. That's fine. No issue talking about that. But the security pieces are very exciting, particularly what we're seeing from, the stories in the field. That one with that Louisiana service provider was an eye opener for us. They just coincidentally told that story on our call about 3 weeks ago, that they were getting DDoSed by their customers and how much bad traffic they're getting over DNS from their client base. I'm sure that's something that's on your guys' radar. So in closing, thank you. And let us know if you have any questions. Thank you, EdgeTeam.
Yeah, thank you. Thanks, Scott.
Yep.
Thanks, guys.
Thank you.